Hey everyone, welcome back to another video of Engineers Academy. And guys, in this video we are going to talk about the laws which is used in thermodynamics. These are nothing but the gas laws which is used in thermodynamics. So guys, these gas laws are very much essential to calculate the pressure, volume, temperature and the entities which is related to the gas. As we all know, these liquids are perfectly incompressible while the gases are compressible. The pressure, the volume, the temperature, as this the values varies, the pressure, temperature and volume. So that's why there is a considerable change in the gases which occurs. So guys, over here these are the laws which relates to your pressure, temperature and volume. These are nothing but the Boyles laws, Charles laws, Gay-Lucas law. So guys, in this video we are going to talk about the first, that is the Boyles law, which relates to your pressure and volume. So guys, before going to today's topic, I just request you to please consider subscribing to my education channel Engineers Academy, and guys please press the bell icon so whenever I upload a new video you will get instant notification. Also guys, please watch my all the playlist of automobile engineering, material science, like related to your total quality management. So you can check out all my playlist and all my videos guys. So guys, without wasting any time, let's begin with today's topic, that is of the Boyles law in your thermodynamics. As we have seen, these particular gases are having the different variables, that is nothing but the gases are having a certain pressure, certain volume and certain temperature. So over here this particular Boyles law states that when we keep temperature as a constant and and there will be this particular pressure is inversely proportional to your volume. As the pressure increases over here, the volume reduces, and by keeping the temperature constant. So that's why you will get a graph like this your pressure. As the pressure increases, your volume decreases, and as the volume increases, the pressure releases. So guys, this is the simple Boyles law. So this particular Boyles law is invented by Mr. Boyle, and basically this he just studied the relation between your volume and the pressure. So this particular Boyles law is suitable for your volume of gas and pressure. So basically over here this particular volume is, or else this particular pressure is inversely proportional to your volume. So over here this equation termed as pressure is equals to 1 upon your volume, that is equals to pressure is equals to 1 upon V. But over here this pressure is equals to K into 1 upon V. So over here K is the constant of proportionality basically. So as like by keeping K on the right hand side, we can call it as a PV is equals to K, that is equals to product of pressure and volume, that is the remains constant for a given particular stage, that is PV is equals to K, that for a given particular stage. So this particular Boyles law is is very much essential to carry out your pressure and volume at different stages over here. At first stage, this pressure and volume, suppose in a closed isolated system or else in a closed system, basically this particular initial stage is having the pressure at P1 V1, and at the final stage the pressure is having P2 V2. So then in that case the change in the pressure or else change in the volume is constant. As the pressure increases, the volume decreases, but in the both the stages, that is at the initial stage and in the final stage. So over here this K remains constant. That's why the equation can be termed as this P1 V1 is equals to P2 V2 is equals to constant. So that's why this particular Boyles law is only suitable for your pressure and volume. And by using this particular law, we can one can calculate the pressure and the volume relationship between the two stages. So guys, let's take one example over here. Suppose the tire is having a volume of 12 mm cube, that is the 12 cubic millimeters, and then it is having a pressure of 15 psi. So that is the first condition. Suppose if I reduce the volume to 10 millimeter cube, that is 10 cubic millimeter, then what will be the the pressure? As this particular volume reduces, the pressure will increase. In the previous stage the pressure was 15 psi, so that's over here we can say that this P1 V1 can be of the P1 is your initial pressure, that is of the 15 psi, and V1 is the initial volume, that is of the 12 cubic millimeter. So that's why P1 V1 is equals to P2 into V2. So that's why over here V2 is nothing but your 10 cubic millimeter. So like over here we got that P2 on the right hand side, and over here this P1 V1 divided by your V2 gives us the value of P2. So if we calculate this particular equation, we will get the value of P2 as 18 psi. So that's why as the volume reduces, your pressure starts building, pressure will increase over here. So that is nothing but the Boyle's law. So this particular Boyle's law is suitable for only the pressure and volume. You have to just set this particular thing in mind. This particular Boyle's law is suitable for the pressure and volume. So guys, I hope you understood this simple law, that is of the Boyle's law, which is suitable for the pressure and volume. So guys, in our next video we will check out the Charles law, and in the further videos we will see the Avogadro's law, Charles law, Gay-Lussac's law, ideal gas law, and combined gas law. So guys, thank you for watching my video. Please do subscribe to my education channel, Engineers Academy.